Karishma. I am currently in second year of Electronics and Communication Engineering at VVIT University. Today I will be presenting on the topic of probability and exams. Before we start, let's briefly introduce myself. I have always enjoyed exploring concepts that connect theory with real life situations, and probability is the one such a concept. Whether it's predicting outcomes and analyzing data, or even understanding everyday chances, probability plays a very important role. Through this presentation, I will be walking you through the basic axioms of probability and how they form the foundation of solving many real world problems. Thank you, and let's get started. Now, probability. Probability tells us how likely an event is to happen. One common way to define probability is by observing how often an event happens when we repeat an experiment many times. Probability in terms it measures of how likely an event happens. It tells us the chance of occurrence of something expressed as the number between 0 to 1. If the probability is an event of 0, it is impossible. If it is the probability of 1, it is a certain event. For example, when tossing a coin, the probability of getting head is a 0.5 chance. There are two equally possible outcomes. Similarly, rolling dice and getting 3 has a probability of 1 out of 6. Probability is not just about coins and dice. It widely used in weather forecasting, stock markets, and even everyday decisions. In short, probability helps us for uncertainty and making informed predictions. Here we have an example to understand probability using relative frequency. Let's say event A is getting head in coin toss. Now instead of tossing just once, we toss the coin 100 times. Each time we toss, we record whether a head appears or not. Suppose after tossing 100 coins, head appears 48 times. So the number of times event A occurs is 48 and the total number of trials is 100. Now probability can be estimated using frequency is equals to number of times event A occurs divided by total number of trials. That is n of A by n is 48 by 100 which equals 0.48. This means the probability of getting a head this experiment is 0.48. But in real experiments, due to randomness and variations, the result may not be exact, but it will be close to 0.5 when we increase the number of trials. As we increases the number of trials, the relative frequency stabilizes and approaches a fixed value. The fixed value of the probability of A. Now, properties of relative frequency. Property 1. Bounded between 0 and 1. 0 less than or equal to f by a by n less than or equals to 1. It's a property 1. N of property 2. Total adds upon 1 for all outcomes. It explains sigma n of a by n is equals to 1. It's a property 2. N of property 3. Depends on number of trials between more stable. As n limit tends to infinity. Its property 3 and property 4 may differ from theoretical values, especially in the small sample sizes. And property 5, additive for mutually exclusive events. N of A union B by N is equals to N of A by N plus N of B by N. It's property 5 and property 6. Used to estimate the experimental probability provides empirical data where theory is unavailable. Classical definition of probability. The classical definition of probability states that if all the outcomes of an experiment are equally likely, then the probability of an event A is given by. Now the definition of classical of probability. P of A is equals to number of favorable outcomes to A by total number of equally likely outcomes. It is the definition of classical of probability. We see this example. When we roll a fate die, total outcomes is equal to 6. Numbers 1, 2, 3 and 4, 5, 6. Let A event A is getting a 4. The favorable outcomes is 1. Only the number 4. Then the event P of A is equals to 1 by 6. Now we discuss about probability introduced through axioms. Here in the axiomatic approach, the probability P of A of an event A is defined as a real number that satisfies the following three axioms. Actually, the axioms are classified into three categories: axiom 1, axiom 2 and axiom 3. And axiom 1 is non-negativity. Now we discuss about non-negativity. The probability of an event is non-negative real number if that is P of A greater than or equal to 0 for any event. If P of A is greater than or equal to for any event, it is known as non-negativity. And now we discuss about axiom 2. If the probability of a sample is 1, if P of S is 1, then the event S is an universal set. It is called as universal set and it is a sure event. If it is 1, then it is said to be sure event. Therefore, if the probability is always getting 1 in the axiom 2, if P of phi is equals to 0, then the probability of a null event or an impossible event is always 0. It is known as axiom 2. And now we discuss about axiom 3. Now, axiom 3. We discuss about axiom 3. This is the last axiom. If a sample A of n has n events, n is equals to 1, 2, 3 and so on n number of times, where n may be infinity and if all the events are mutually exclusive. In this sample, we take number of events n from 1 to infinity. If n be the infinity, then the events are said to be mutually exclusive. For example, if we take the definition, A of m intersection A of n is equals to 5 for all m not equals to n. Then we use this formula in axiom 3. P of union n is equals to 1 to n, then A of n is equals to sigma. N is equals to 1 to n, P of A of n. This is used for mutually exclusive. This is the formula for mutually exclusive. If for rather another, we use P of A1 union, A2 union and so on union A of n is equals to P of A1 plus P of A2 plus and so on plus P of A of n. We continue this formula until infinity. These two are the formulas for axiom 3. We use this in cases of mutually exclusive. So to conclude my presentation, we started with the basics idea of probability. Simply put, it measures how likely an event to be occurred. We say that probability values always lies between 0 to 1, where 0 means impossible and 1 means certain. To understand it better, we looked at examples like tossing of coins and rolling of dice, whether we could calculate probability based on the possible outcomes. Then we also discussed the axioms and probability. Where are the fundamental rules introduced by? These axioms are simply but very powerful. First, probability of event is always non-negative. And second of the probabilities, entire sample space is always 1. And the third one is if two events are mutually exclusive, the probability of either occurring is the sum of for individual probabilities. These rules act the foundation for solving complex problems in probability. Through the coin of toss example, we also saw how relative frequency gives us an experimental way to estimate the probability and how results get closer to the theoretical values. When we increase the number of trials, this shows us balance between theory and practice in probability. Overall, the probability is not just a mathematical concept, but a tool we use daily, whether in predicting weather, analyzing data, playing games, or even making decisions in uncertain situations. It gives us logical framework to deal with uncertainty. So probability and axioms are not just academic topics, but essential concepts that guide us for both real life applications and higher studies in mathematics and engineering. And this is the topic, and thank you for listening. Thank you.